Welcome to section 11.2, length, area, volume, and dimension. Please read over the topics and objectives, standards, and vocabulary and concepts. So all physical objects have several different measurable attributes. So if you think about a spool of wire. So if we're talking about a spool of wire, we've got the length of the wire. We've got the thickness of the wire, we've got the weight of the wire, and those are the most common measurable attributes. We've got length, area, volume, and weight. So in this section, we're going to study those as related to the concept of dimension. And although these concepts may seem advanced, the foundations for understanding them can be formed early in elementary school. So when children make shapes by placing sticks end to end, or when they lay tiles or build with blocks, think of their work as exploring length, area, volume, and dimension. So the units for length, area, and volume are related, so it's easy to get confused about which unit to use when. So most real objects have one or more aspects or parts that should be measured by a unit of length, another aspect or part that should be measured by a unit of area, and another aspect or part that should be measured by a unit of volume, and we're going to talk about each of those. So first, let's talk about length. So when we talk about length, these are the units. We've got inches, centimeters, miles, kilometers, and of course, all sorts of different variations. But these are the questions we're asking. How far? How long? How wide? So if we were talking about molding, we would say how much molding or how long of a piece of molding will I need to go around the ceiling? So the answer would be in feet, and then it would be the number of foot-long segments that could be put end to end to go around the entire ceiling. And length describes the size of an object that is one-dimensional. So the length is how many of the chosen unit it takes to span the object from one end to the opposite without gaps or overlaps. And we can use parts of a unit too, right? Could be a half or a quarter. So roughly speaking, an object is one-dimensional if at each location there's only one independent direction along with which to move within the object. So imagine a creature living in a one-dimensional world, and that creature would only be able to go forward and backward. So these are examples of one-dimensional objects. Perimeter is a measurement of length. It is the distance around the shape or the total length of the outer edge. It is the outer edge around a flat shape, and that is one-dimensional. So it wants us to find the perimeter. So the perimeter is the entire length. So we need each little bit. So we've got this length, this length, this length, this length, and this length. Well, if we know some of these, we know that this one is equal. So we know that that one's 30 and we know that that one's 9. So actually we've got all these lengths, but we need to figure out this length here. Well, we know that this little piece here is 6 feet. And then this little piece here is 12 feet. And then that little piece there is 7. So this whole length, we can add that all up. We're going to get 25. So the perimeter is equal to, and I like to kind of make a note where I start. So it's 6 plus 9, and I'm just going around 6 plus 9 plus 12 plus 9 plus 7 plus 30 plus 25 plus 30. So when we type that into our calculator, we end up getting 128. And it's important that we use the units here, feet, regular feet, because we're in one dimension and we're using 128 1-foot long units. So go ahead and do these. We've got 1, 2, and 3. Press play when you're ready to see the solutions. And there you go. Now let's talk about area. Area is square feet or square kilometers, and they're going to answer questions about how much flat material does it take to make something, or how much flat material to cover. So we're talking about covering. So how much carpet do I need to cover the floor? So the answer would be in square feet, and it would be the number of 1 foot by 1 foot squares. So we're talking about the whole square that it takes to cover. Without gaps or overlaps. Area is two-dimensional, and so there's two different kinds. There's area and surface area. And surface area is just, you'll see how we use it a little bit later, but it's the entire surface if we've got more than one, right? Area is just a piece, and then surface area would be if we had more than one. And it's two-dimensional, and how much it takes to cover the object without gaps or overlaps. And then the surface area, as I said, of a solid shape is the total area of its outside surface. And so we're talking about two-dimensional here. So if you want to think about an imaginary creature, this creature can go forward and backwards. So that's length, right? Just forward and backward, but can also go left and right. So it's kind of filling up more space. Whereas our one-dimensional character could just, you know, go forward and backwards. Now we can go in two different directions and cover space. But it can't go up and down, right? I can't get off the page. I can't go in those directions. So here are some two-dimensional objects, you know, the inside of something, the surface of something. And remember that we use that exponent of 2. All right, and that's another way to remember two-dimensional objects. Oops, sorry about that. Where'd we go? Okay, here we are. And now let's talk about volume. So volume is how much air is in the room. We're talking about stuff that gets filled. We're talking about cubics. And so it'd be how much of a substance is in or can fill. So if we look here, it's how many 1 foot by 1 foot cubes fill the room. And it's three-dimensional objects, and we're talking about filling it without gaps or overlaps. And so if we're still talking about that imaginary person, they can go in all directions. They can go up and down and left. Oops. They can go left and right, and then they can go in up and down, right? And they can go in all different directions, and it might take a little bit of imagination to imagine that, but you know, we're talking about these kind of cubes here, or any shape that is three-dimensional that can be filled. So here are some examples. Let's do an example. So use unit cubes to find the volume of a right rectangular prism with width 4, length 5, height 3. All right, let's see here. So we're talking about, and I'm just going to kind of draw it here just to make sense of it. Always like to draw. So we've got a width of 4, a length of 5, and a height of 3. So what this is saying is how many cubics can I fit in here? So 1, 2, 3. That would be 1, 2, 3, 4. And this is like 1, 2, 3, right? This is like 1, 2, 3, 4. Okay, so I should have made it 1, 2, 3, 4, 5. Should have made that a little bit longer. So here would be like a cube. Like how many cubes can I fit in it? Don't worry, I've got a much better drawing on the next slide here. But now I'm going to build it out. So I'm building 4 cubes across. 1, 2, 3, 4, right? Because I got 4 across. And I've got to go, and I want to go back 5. So I'm going to do, you know, that's 1. And then I'm going to go this one, this face right here. And then 2, 3, imagine those are cubes, 4, 5, 1, 2, 3, 4, 5. And then I'm going to go high, right? I need to go 3 high. So on top of this cube here, I'm going to go 1, that's a cube, 2, 3. So how many fill this? Well, let's look here. I have a row of 4. And how many rows of 4 of these am I going to have? I'm going to have 5. So altogether, I'm going to have another row of 4. So that's 4. And then I'm going to have another row of 4. That's 8. I'm going to have another row of 4. That's 12. And then 16. And then 20. So that's 1, 2, 3, 4, 5. Oh, my picture's so bad. Sorry, guys. I've got a better one on the next slide. And then I'm going to go 3 high. So on top of that, so I've got 20 laying the base of this figure. And then how many rows of 20? Well, I'm going to stack another row. So that's going to be another row of 20. That's my first row. It's my second row. So now I'm at 40. Then I'm going to add another row. So that's going to be 60. So this is going to be 60 cubic yards. Whew, let's look at a better picture, shall we? And this is from that website I showed on the previous section. So we've got 4 back, 1, 2, 3, 4. We've got 5 across, 1, 2, 3, 4, 5. And then we're going to go, we've got 20 in our first layer, and we're going to have 3 layers. So we're going to have 60 cubic yards. Go ahead and give this one a try. Press play when you're ready to see the solution. And there we go. When we come back, we'll compare length, area, and volume all together.